All right, good morning to all of you.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Let's start. Today we will discuss the last part of the number synthesis. Yesterday we discussed the possible number of links in a mechanism with 6. Okay. Now let us start from this. So today is what is the lecture number? Today is 6. This is the 6th lecture. Okay, I'll discuss today. As we know that number of links in a mechanism number of links in a mechanism with simple hinges simple hinges. What conversation you are making here?
Sir, your screen is
Okay,
not visible.
okay. Doing that. Is it now visible?
Yes, sir.
Yes.
Yes.
Okay. Okay. So number of links in a mechanism with simple hinges is even, right? And we have discussed about this. And what is the minimum number of link in a mechanism with simple hinges? What is the minimum number?
Four.
This
Four.
Four.
is
Four,
4.
sir.
Okay.
For
So with this, we have started with n equals to 4. We discussed n equals to 6. What kind of mechanism can be constructed? Now, what is next? What is that?
n is
What is the
equals to
next?
8.
Eight.
Okay, so
8.
today we will discuss this n equals to 8. Small n or capital N, n equals to 8. Today we will discuss this. So first is, if suppose the number of links in a mechanism is 8, what is the maximum order of link?
Fourth. Fourth. Four.
So I max is equals to n by 2. This is 4. Okay. So we can have, that means total number of links. Total number of links in a mechanism, if we calculate n equals to n2 plus n3 plus n4. Can we have n5?
No, sir.
No,
We
sir.
cannot have n5, right? So n3, n2 plus n3 plus n4, this is the only possibility. So we can write here n2 plus n3 plus n4 is equals to 8. This is our equation 1. Okay, now from Grubler's criteria, we will now use Grubler's criteria. Using Grubler's criteria, you know that this is 2j is equals to What is the formula?
3n minus 4.
3n minus 4. Okay, this is the formula. And what is this value? From here you can see that 3 into 8 total number of links. So this is equals to 20, right? So from here we get 2j equals to 20. Let us call it 6.2. Now we apply the definition of element. From the definition of elements, some equation we had earlier in our, when we have discussed this, you see this 2j equals to something. So if I call this equation, in which lecture we have discussed this? Lecture 3. In lecture 4. In lecture 4 we have discussed this. If I call this equation 4 point C, okay, and refer to this equation here, from the definition of elements 4 point C, this equation, what was the equation? 2j
2j
equals
is
to
2n2
2,
plus 3.
2n2 plus 3 n3 plus 4 n4, because 5 and 5 is not possible, right? For this case, the maximum value of this I is 4. Okay, so from this, again, if we write them in this left hand side, 2n2 plus 3 n3 plus 4 n4 is equals to 20, because from 6.2 we know that the 2j equals to 20, right? So let us call this equation 6.3. Now actually we want to find out how many n2s are there, how many n3s are there, and how many n4 are there. But we have only two equations, 6.1 and 6.3. These two equations and three unknowns. These are the two equations, and we have three unknowns. Can you solve this? Two equation and three unknowns. Can you solve this?
No, sir.
No.
No, sir.
So from 6.1 and 6.3, what we can say, n2, n3 and n4 cannot be solved. Cannot be solved. It can be solved, cannot be solved uniquely. So you cannot get unique solution. You can get solution, but those solutions are not unique. But can we have any number of solution? I mean, means infinitely many solutions. No, we don't have infinitely many solutions. Why? Because n2, n3, n4 have to be positive and integer. Any value they cannot take, right? This is a number of link. So you cannot say that 2.5 is a number. That can be a solution to this equation, but then there is a restriction that 2.5 cannot be a number. So either you use 2 or 3. Okay, this way the number of solutions are not infinitely many. That is restricted. Another restriction is there. Okay, so there is a restriction that how many n2 should be there? In a mechanism, we discussed that how many binary links should be there in a mechanism. Minimum number of binary links in a mechanism. N2 minimum. What is this number?
4.
4.
This is 4. So that means there is a limitation. When we apply this limitation, so let us call it 6.4. So when we apply this limitation, we can start with this. Suppose that n2 equals to 4. Let us start from this n2. n2 equals to 4. Then your 6.1 will give us equation, some equation. What is that? n2 plus n3, sorry, n3 plus n4 equals to 8 minus n2. n3 plus n4 equals to 8 minus n2. In this case, n2 we have taken 4. That means this is 4. Okay. Similarly, equation 6.3 also gives us something. What is that? 3n3 plus 4n4 equals to 20 minus 2 into 4. What is this?
12.
12. Now can you solve this too and give me the values of n3 and n4? Solve this equation and tell me what is the value of n3 and
N3 is
n4.
equals to 4 and 4 is equals to 0.
Okay. So then what is the next possibility? We can take n2 equals to 5. Right? If n2 equals to 5, then 6.1, this equation gives you what? n3 plus n4 equals to 8 minus 5 equals to 3. Similarly, 6.3, this equation will give us n3 plus n4 is equals to 20 minus 2 into 5. What is this? Can you solve this too? And tell me the value of n3 and n4.
N3 is equals to 2 and 4 is equals to 1.
2, 1.
What is the next possibility? We can take n2 equals to 6. For that, 6.1 gives us n3 plus n4 is equals to 8 minus 6 is 2, and 6.3 gives us 3 and 3, 4 and 4, 20 minus 2 into 6. What is the solution?
1, 1.
नहीं ठीक से बोलो.
0, 2.
N3 is equals to 0 and 4 is equals
and
to 2.
N3 0.
And 3, 3 and 4, 2.
0.
Okay. So can we go for n2 equals to 7? Then 6.1 gives us n3 plus n4 is equals to 8 minus 7, and 6.3 gives us 3 and 3, 4 and 4 is equals to 20 minus 6. Can you solve this too?
Sir, N3 minus 2 and 4 is equals to 3.
n3 equals to minus 2, n4 equals
N4
to.
is 3.
So is it a feasible solution?
No, sir.
No, sir.
No, sir.
It is not a feasible solution, right? n3 cannot be negative. That means this solution, we cannot take this solution. So we cannot take this solution. So this is not feasible. So with, can you see now the limitation of constructing a mechanism? You cannot take any number of links or any number of any order in that mechanism. Okay. So similarly, if we go for 8, n2 equals to 8, then can we have something here? What is the value of n3 and n4?
0.
0, 0.
0, 0. So you can construct a mechanism using only 8 number of binary links and simple hinges. So what we will ask you to do, try to construct some mechanism as we did here for number 6. So we have two solutions. Okay, we have only one solution, 4 and 2. N2 is 4 and 3 is 2. And using these two, we have we have got these two mechanisms. Okay, and practical applications are this. Now, can you just get this kind of mechanisms from these combinations? Like for the first case, you have 4 binary link and you have 4 ternary link. So 4 binary, 4 ternary, you can construct a mechanism. Not one mechanism, you can have many combination of mechanisms. Do that. This is your homework. Okay. Construct the mechanisms with 8 number of links. This is your assignment 1. Construct mechanisms, construct possible mechanisms, all possible mechanisms with 8 links and simple hinges. Okay. So you will submit this assignment. This is due on today is 19. So you will submit it on 19th, 1 week, 26th. 26th is a holiday. Before 26th, you need to submit. So this is your assignment 1. Now we will move to the topic which is called range of motion of a 4 bar linkage. Have you studied this range of motion of a 4 bar linkage?
No, sir.
This is also called Grasshopp's criteria. क्या spelling है? Grasshopp's. HOF. Okay, this is called Grasshopp's criteria. We are going to study this. Up till now, the discussions we made in this number synthesis, we only know what is the effective degree of freedom of a, suppose there are n number of links in a mechanism and they are connected by hinges. So what will be the effective degree of freedom? And then we have studied what is the minimum number of link in a mechanism, minimum number of binary link in a mechanism, and then we have studied maximum order of link in a mechanism. All those things we have discussed, and also we have discussed the possibility of mechanisms, constructing mechanism with link and number of links, like 4, 6 and 8. But all these discussions and calculations will not tell us anything about the movement, whether it will rotate or not rotate, how much it will rotate. That we have not obtained from these discussions. And it is really a very essential topic, but very difficult. And only possible formulation can be done for a four-bar mechanism. For other mechanisms, means complicated mechanisms, you cannot done a formulation. So let's do that for a four-bar mechanism. What is the range of motion? Okay. So already you have studied what kind of for a four-bar linkage. Suppose we have a four-bar linkage mechanism like this. Suppose we have a four-bar linkage mechanism like this. So this is our link number 1, 2, 3, and 4. Four-bar linkage mechanism. What are the different mechanisms can we get from this four-bar linkage? What are the different mechanisms we get from this four-bar linkage?
Double
Crank rocker,
crank,
crank rocker,
double
Eh?
slider,
rocker.
double crank, double rocker, and rocker crank.
Double crank, second is crank rocker, and third is, what is it? Double rocker. This three kind of inversion we get from this four-bar mechanism. What do you mean by this double crank?
Both will rotate completely 360 degrees.
Both means which one? Which both?
The
All
one
of
besides the fixed
Eh?
one.
Eh?
And
the
there is
two
the
and
fixed side.
two and four,
Two and four.
If I call this
Adjacent to fixed.
crank and if I call this follower, this is coupler.
Both 2 and 4 will rotate 360 degree.
So crank and follower have complete rotation. Okay, for this case, crank rocker,
So one will oscillate and one will rotate 360 degree.
one of the link will rotate completely, complete rotation of 2 or 4. दोनों नहीं, 2 or 4, and 3 will oscillate. Other link oscillate. ठीक है. And what about double rocker?
Both
What
2 and
about double
4.
rocker? Both crank and follower will oscillate. Both crank and follower oscillate. That is called double rocker. Now, how you can say that? Is there any relation between this motion and the dimensions of these links?
Yes, sir.
What is that?
So length of
S
two.
plus L is less than equals to P plus Q.
eh? S plus
L is less than equals to P plus Q.
तो तुम लोग बोल रहे हो कि you have not studied this. Hmm? S L plus S less than P plus Q. So where L is the length of the longest link. Longest link, and S is the length of the shortest link. P and Q are the length of other two links. Okay. Now let so this is the condition. If this condition is followed, then you get these mechanisms. Okay. Or this is the what is this condition called? If this condition is true, then what happens?
Continuous
Sir, we
repeating
can,
motion.
sir, we
Hmm?
can get different mechanisms.
If this condition is not satisfied, then
Then, sir, only a rocker mechanism.
Double rocker.
okay. So if this condition satisfied, then you can get something is happening, something ensuring this condition. What is that?
Sir,
Complete
complete
rotation.
rotation.
One
Yes.
trying to
We get the continuous motion.
Complete rotation of one link. Okay. Complete rotation of one link with respect to other links. That is this condition. All right. Now let us see the condition for complete rotation of these links with respect to link 1. Okay, with respect to link 1, we want to find out with respect to link 1 what is the condition for suppose link 2, we want to make it complete rotation with respect to link 1. Okay, what is the condition for that? Similarly, we want to find out what is the condition if we rotate link 3 with respect to 1, link 4 with respect to 1. If we can have those conditions, on the other hand, because all these links are connected, on the other hand, you can also say if this 2 can rotate with respect to 1, on the other hand, you can also say that you keep these 2 fixed, then 1 can also completely rotate. Means if 2 can rotate completely with respect to 1, then 1 can also rotate completely with respect to 2. Do you agree with this? If 2 can rotate with respect to 1, then 1 can also rotate with respect to 2. In this case, this link 1 is fixed, but you can remove this fix. I can fix this 2. Okay. Do you agree with this point or not? If
yes, sir.
link 2 can rotate with respect to 1, then 1 can also rotate with respect to 2. Because the motion is relative. 1 is rotating with respect to 2. 2 को fix कर दो, then 1 will, 2 is rotating with respect to 1. Now you fix this 2, then for the same kind of motion, 1 will rotate with respect to 2 only in the reverse direction. Okay, so let us get the conditions for all these things. So what we will do now, we will now get take a condition where link 2 has to make a complete rotation. We'll now explore the condition for link 2 has to make a complete rotation. Now look at this picture. This, so link 2 is here. If it has to make a complete rotation, then it has to at least cross two very extreme positions. One of the extreme position when 2 comes to this position, right? 1 and 2 are on the same line. At that point of time, maybe 3 is like this and 4 is like this. On the other hand, 2 can be this extreme. Okay, these are the two extreme position of 2 with respect to 1 I am drawing, and then at that time maybe 3 can be here and 4 can be like this or somewhere according to the okay, like this. So let us find out what is the condition to be satisfied so that these extreme positions uh, at the extreme positions there is no restriction for link 2. Means on the other words we want to say without any restriction 2 can rotate. Okay, so it has to cross these two extreme positions. Do you understand these extreme positions, these two extreme positions?
Yes, sir.
Yes,
So
sir.
I am now drawing, this is link 1 and we are saying link 2 is on the same line with link 1. So this is that line and then maybe link 3 is like this. So link 4 is this one. Okay, this is link 1, 2, 3, 4. We can have another extreme position. We are drawing it here. This is, okay, let us draw first. Link 1 and link 2 is like this. So here we assume one thing, assuming link 2, length of link 2 is greater than length of link 1. This is our assumption. We started with this. Okay. Now, if that is the case, then maybe with link 2, there is link 3. So maybe link 3 is like this, or maybe link 3 is like this. Now that depends on its length. And link 4 is this one. So this is link 1, link 2, link 3, and link 4. Okay. Now let us give some name. So this is O2, O4, and A, B. O2, O4, A, B. So for this triangle, for this triangle here, I am writing one condition, that is L1 plus L2 has to be less than L3 plus L4. Is it fine for this triangle?
Yes, sir.
Yes.
Okay. Now for this triangle, we can write here that this just consider L4. Just consider L4. L4 must be less than L3 plus L2 minus L1. Agreed?
Yes, sir.
Hello?
Yes, sir.
And we can also have L3 must be less than L4 plus L2 minus L1. Right? Is this fine? Last equation.